we talked about PDFs and CDFs, right? So PDFs, just to recall, we saw that PDF is the probability density function. It's a table, right? It can be a table, it can be a graph, but the table brings to us the values that your random variable can assume. For example, 0 and 1 for a fair toss of a fair coin, and the probability of that happening. Okay, so what's the probability of when little x is 0, or tails, what's the probability of this happening? Well, if it's a fair coin, it will be a half, right? What's the probability of your variable you have an outcome of 1, your variable is equal to 1? Well, again, if it's a fair coin, it's a half. Okay, so this is the most simple PDF that we have. Okay. Then we saw a CDF, right? So CDF is also a table, but it's a table that eases our assessment of probabilities when we're talking about less than or greater than, right? So the table is always less than. We will see how to transform this into more than. But for example, in this column, in the first column, it also brings the values that your variable can assume. For example, 0 and 1. And the probability of assuming less than that. So what's the probability of when my little x is 0? What's the probability of being less or equal to 0? Well, it's just equal to 0 because I don't have nothing less than 0. Right? So we saw the property of the CDF is that this line here, like the first line of the CDF, is always equal to the first. Okay? Because the probability of being less than or equal to 0, in the end of the day, is just the probability of equal to 0. Okay? Now, what is the probability of your variable being less or equal to 1? Right? Well, it's the probability of being equal to 1, right? So it's a half, plus the probability of being less than 1, which is 0, right? So it's a half plus a half equals 1. Okay? So this is PDFs, this is CDFs. Special properties of each one. PDFs, if you sum the probabilities, because this is your sample space, right? You can only have 0 and 1. These probabilities must sum up to 1, and it's true. And for CDFs, you always start, like the first line is always equal to the first line of the PDF, and it always has to end up in 1, okay? Because the last line will always be the sum of this column that has to be 1, okay? So this is just a recap. And then the last item that we talked was about going from one to the other. So going from PDFs to CDFs, okay? And we did this first example. Here we went from PDF to a CDF. And let's just kind of reassess this. So here is what I did here is I collapsed both the PDF and the CDF because they all have this common column here, right? So I just put it one beside the other. So this here is the PDF. This is the CDF. So if you're given the PDF and you want to construct the CDF, you should start always like this. What's the probability of x being less than or equal to -1? Well, the less than part doesn't exist because I don't have any number less than -1. Actually, the first line is always the probability of x being equal to x, right? So what's the probability of my random variable being equal to -1? It's 0.4. So the values of the CDF are also always equal to the PDF in the first line, okay? It's 0.4. Now, what's the probability of my variable being less or equal to 0? Well, that is the probability of being equal to 0, so I can come in the PDF and assess that. That's 0.2. Plus the probability of being less than 0. Well, it's 0.4. So I just sum up that values, okay? This is 0.6. What's the probability now in this line here? What's the in this row? I'm in this row. What's the probability of my random variable being less than or equal to 1? Well, it is the probability of being equal to 1, which is 0.3, and it's given in the PDF, plus the probability of being less than 1, which is the probability of being 0, and the probability of being 0.4. So what I'm doing is I'm summing up all these three rectangles, 0.3 plus 0.2 plus 0.4, which is already the 0.6 from the line above, okay? And this will sum up to 0.9. And finally, now let's do the last line. What's the probability of x being less than 2, less or equal than 2? Well, it is the probability of being 2, plus the probability of the line above, plus the probability of the line above, plus the probability of the line above. So it's the sum of everything, and the sum of everything has to sum up to 1. So a CDF will always end up being 1 in the last row, okay? Cool? So you can go thinking and reasoning just as I did. Kind of it's this one plus the other ones, or you can do like the algorithm. It's very algorithmically. It's very like having a rule, right? So the rule is this. If you do the rule is this. First, copy the first column, the first row. Put a 1 in your final row because you know it has to be that. And then go like this. This plus this equals 0.6. Now 0.6 plus this equals 0.9, and then you're done. Okay, so it's just an algorithm. Okay? So always do this movement of summing up this point plus this, and this point plus that. Okay? Questions? So this was done in the last lecture. Questions about this? No? Cool? All right. So now we want to go from the CDF to the PDF. So let's say that you are giving the CDF, right? So it's the same problem, but imagine that I'm asking you on the test, I say, well, look, here's my CDF. Please, can you find me the PDF, the original one? Okay. So how can we do that? Well, think about this. The first row is always the same, right? We know that. So it's always the same, the first row. Okay? Now, the way to go from the CDF to the PDF is to go from the bottom to the top. So the reasoning is like this. You have summed up something to 0.9, right? You have summed up something, a blob here. Oh, sorry. You have summed up the blob here to 0.9 to give you 1, right? So 0.9 plus the blob gave you 1. How much is the blob? 0.1, right? Cool? Now, the same thing here. Think about this blob. You you had 0.6, you summed up to the blob, and it gave you 0.9. How much is the blob? 0.3, right? So it's just reversing your reasoning for the PDF. Now, you had 0.4, okay? How much you had to sum up to a blob here that gave you, sorry about that, let me just turn this thing off. How much you have to sum to 0.4 to give you 0.6, 0.2, right? So that's, so if you go with the arrows, if you're going from CDF to PDF or PDF to CDF, if you follow this reasoning, top to bottom, bottom to top, you will be able to go from one to the other. Okay? Questions? Nice. All right, so just for us to practice, just let me get rid of this. This is a practice exercise. Okay, so here I give you a PDF, right? I give you a PDF, and I want you to find me the CDF. Okay? So let's do it together. Let's do it in an very automatic, algorithmically form, just to practice this without kind of you bothering of the steps. Let's just do the algorithm, okay? So what is this? Well, I know that the first line is always the same, right? I do know that it's always the same. And I also do know that I have to end in what? Okay. All right, so what should I do? Well, remember the arrows. This plus this will result in 0.3. Now 0.3 plus the next one has to result in 0.5. And then you can always use the last row to check. 0.5 plus 0.5, thank God it results in 1. So you're good. Okay? So I always like to use these arrows to kind of guide me in doing the PDF to the CDF. Questions? All right. So now let's try to do the opposite. Let's go from the CDF to the PDF, okay? So the first thing that I do know, where is it, is that my first line must be the same, right? Okay. Now, I go from the bottom to the top, okay? And I will use the algorithm. I'm not going to reason the numbers. I'm using the arrows to just guide me. So what is that it's happening? Well, I've summed something here with a half to give me 1. So what is this thing? It's a half, right? Okay? Now, I summed something here with 0.3 that gave me the half, 0.2. Now, I summed something here to give me 0.3. That's 0.1. Okay? So you can use the arrows, and you can also think like this. If this is a cumulative distribution, you just accumulate, right? So you start with 0.2, then you sum up 0.1, that's 0.3, then you sum up 0.2 to 0.3, that's 0.5. 0.5 to 0.5, that's 1. So this is the CDF. It's cumulative. And if you think about going from the cumulative to the not cumulative, you just subtract. 1 minus a half is a half minus 0.3 is 0.2, 0.3 minus 0.2 is just 0.1. Okay, so, but this is practice. Okay, just practice. Now, there will be at least 2 questions of going from PDF to CDF in the test. So it's a good thing to practice, not tomorrow. This is final, right? In the final, you will find at least 2 questions. One, usually it's an open question where you will have to construct the CDF or the PDF from one another. I don't know. It depends on the year. And one multiple choice question as well that you will have to know how to go from one to the other. So this is it's very important for you to practice this exercises, okay? Good? Questions about this? No? We're good to go. All right. Now, when I told you guys that the CDF actually helps us answer questions of, oh, what's the probability of something being less than or equal to something? That's true. What's the probability of things being greater than equal? That's also true. But the thing is that the CDF, the way it is, it only shows directly on the table the less than, right? So how could that facilitate my life, right? What if I ask you the greater than something? Well, it actually does facilitate because you don't have to sum up lots of things in the PDF, but you have to use the opposite formulas. And they're valid. You know they're valid. They're formulas of probability. So when I ask you what's the probability of X being greater than something, you should use 1 minus the probability of being less than something. And then you just can look up in the table. So you are transforming your problem of greater than, which you don't have in the table. When you use the opposite formula, you're left to find a probability that is less than or less than or equal than, which you can find in the table, right? You can come here and say, oh, it's this value, okay? So let's do some exercises just to experiment with the opposite formulas, okay? So here it is. I have the same PDF and CDF of my random variable. Okay, let me just do this. Okay, and I have 2 questions. Does anybody want to answer me the first one? What's the probability of X being less or equal to 2? No? Nobody? Okay, I'll do it for you then. So what I want is to look in the CDF, right? Why? Because the CDF gives me exactly this probability. It gives me, the CDF gives me the probability of capital X being less than a little x. So what do I want to do? I want that my little x be equal to 2, right? So I go to the row where my little x assumes 2. So a little x will take on 2 here, in this row, right? Okay, so then I just assess and retrieve from the table. Which one? This one, right? This is exactly the probability of x being less or equal than 2, okay? So the answer is 1. I just kind of retrieved it easily from the table, okay? Now, what about this other question? The other question that I'm asking is this. What's the probability of my x being more than 1? Okay? So, or larger than 1. So what I'm asking is this. What's the probability of my random variable being larger than 1? I'm not including 1, right? I'm not including 1. This is not greater and equal to 1. I don't have the equal little sign there. It's just greater than 1. Okay? So I can use the opposite formula. How the opposite formula works? Well, I want, if this is the probability that I want, sorry, this one here, if this is the probability that I want, this will be 1 minus this here, right? So I will do 1 minus the probability of x being less or equal to 1, which is exactly the probability of being 1, being 0, and being minus 1. Okay? Now, I started by asking a question that I couldn't see in the table. But what about now? Well, now I'm only left with this probability here, which is a less than or equal. I have this information on the table, right? I have this information on the table. How can I find this information? Well, right now, my little x has to be 1. All right, so I go here, and I find the row, oops, and I find the row where my x is 1. It's exactly this row. So my little x takes on the value 1 at this row, and I just go and retrieve from the table the less than or equal, which is 0.9. So in the end of the day, the probability of x being equal to is just 0.1. Okay? So remember, you can always use the opposite formula. Let's do another one. So this is A, this is B. Let's do a C one. Well, actually, first of all, questions about the B. Good? All right, so now let's talk about the C one. And I'm going to kind of get rid of this because it's a new example. Let me get rid of this really quick. Not that quick, but trying to be. Okay, so now I want to know what's the probability of x being greater or equal to 1. Okay? So what I want is, actually now I'm including 1. So I'm doing this, right? I'm capping it here. And I want the probability of my x being greater or equal to 1, including 1. Okay? So I'm going to use the opposite formula. How's the opposite formula works? Well, it's 1. Everything here, the probability of everything here is 1. So it's 1 minus this here, right? We'll give you the arrow. So it's 1 minus the probability of x being less than 0. I don't include less or equal than 0. Or you can think about less than 1. Okay? It's easier. So you just keep the same number. Okay? So if I have the equal sign, I don't have the equal sign, I have it here. If I have the equal sign on the left-hand side, I don't have it on the right-hand side. Okay? So now we just carry this on. It's 1 minus. Well, what's the probability of x being less than 1? Well, the probability, where's my pen? Oh, it's here. What's the probability of x being less than 1? Well, it's actually the probability of x being less or equal to 0. This guy here you have. And it's, who wants to try? Who wants, yeah. 0.6, right? So how do you do that? Well, now my little x has to be 0. So I go to the row where my little x assumes 0. It's this one here. Okay, this one here. And I go and I retrieve the value from the CDF. That's 0.6. So this is 0.4. Okay? Questions about this? Oh, there's something bothering me. Okay. Good? All right. So lots of practice at home. It's guaranteed that this will be asked. So for the finals, remember, go to the past tests and try to solve the maximum number of exercises that you have to go to the CDF, the PDF, and you have the opposite formulas working. Okay? All right. So now that we know what is a PDF and a CDF, obviously, I'm just going to introduce something called histograms. Okay, who is in the stats might be very used to it already. But what is a histogram? So a histogram is a way of showing the PDF in the graph form and not in table form, right? Actually, the table form is not common. We start kind of with that because it's easier in terms of discrete variables, but in the end of the day, in your college life, for example, you will see lots of histograms and not the table version. Okay? So what is a histogram? Here's the definition. A histogram for a discrete random variable x, capital X, consists of rectangles of equal width centered over each value little x that capital X can take on. The rectangles will have widths so that they are all adjacent to one another. The heights of the rectangles are chosen so that the area of the rectangle is equal to the probability. Oh my God, right? Like, let's break this down. It's easier than it looks. Okay? So what the definition here is an histogram, and here is the PDF. So what you're looking at in this graph here is exactly what's written in the PDF here. Okay? How it is defined? Well, first of all, we have rectangles that are centered on the values that your variable can assume. So I have I'm doing an experiment, and my outcomes can be 1, 2, 3, or 4. I'm assigning values to the outcomes, okay? 1, 2, 3, and 4. So I will have rectangles centered in these values. I'm doing it a little bit bigger here. Okay? So when you look at a histogram and you find the middle point of the rectangles, those are the values that your variables have, and it's actually the first column of the PDF. Okay? So it's 1, 2, 3, and 4. 1, 2, 3, and 4. Okay? Now, the rectangles, they have to be adjacent to another. Okay? So let's get this little, and they have all the same width. So let's get this rectangle here first. if it has to be adjacent to its neighbors, right? You think about this. This rectangle will have to come up until the middle of the interval, and the other rectangle, its neighbor, also will have to come to the middle of the interval so that they can touch, right? So in the end of the day, both of them will kind of touch in the middle of the interval, which is 1.5. Okay? Same thing here. This rectangle here grows to the right up until the middle of the interval, and this one grows to the left until the middle of the interval, which is 2.5. Okay? And so on, right? So this rectangle here grows to 3.5, and this one here gets to the left of 3.5, and they meet, they kiss in 3.5. They touch in 3.5, okay? Now, it's a rectangle, so if the middle is 1 and you have a half for one side, this should also be a half, right? And there you go. So you positioned your rectangles. You did 2 of the 3 things that you should do for an histogram. First of all, put rectangles centered on your values. Make them touch each other. So you will find the middle points between each other. And the third thing to have an histogram is this. The area of the bar, of the rectangle, should be equal to the probability. So the area of each bar should be equal to the second column of the PDF. Okay? So let's do one of the rectangles. Let's start with this one. The area that I'm kind of how you say this, like when you do like, yeah, the one that I'm shading. Thank you so much. The area of the rectangle that I'm shading, it represents the probability that my variable assumes 1, because it's centered in 1, right? So how much this probability has to be? Well, it has to be 0.2, right? So the area of this rectangle, the area of this rectangle must be 0.2. Okay? Now, what do you remember? Do you guys remember the area of the rectangle? How I calculate the area of the rectangle? Width times height, right? Or base times, I don't know, side, right? I don't know. So like it's one side times the other side, right? So the area of this rectangle will be the width times the height of the rectangle, okay? Now, let me ask you something. We positioned the rectangles, right? How long, or what's the measure of the width of these rectangles? It's 1, right? Why? Well, because it goes from 0.5 to 1.5, right? So if you have a dental floss and you have a ruler and you put the dental floss between 0.5 and 1.5, the length of the dental floss is 1, okay? So the length of this width here actually is 1, okay? So if the area has to be equal to 0.2, the width is 1. How I should set up the height of this triangle, of this not triangle, geez, of this rectangle? 0.2. Well, 0.2. It's exactly the height of this rectangle. You can see here is 0.2 because the area of 0.2 times 1 will give me this probability here of 0.2. Okay? Easy. All right? Let's do the second one. Here is the second one that I'm shading. the area of this second rectangle gives me the probability of my variable being 2. So the probability of my variable being equal to 2 is given by this number here. It's 0.1. Okay? So I'm not going to write it all again. Well, I will still. The next ones I don't. The area, this is in Portuguese. Okay. This area of the rectangle, oh, I did it here too. I'm sorry, guys. The area of this rectangle is the width times the height. And the area should be equal to 0.1. The width is 1. Well, because, first of all the rectangles have the same width. So if the first one had, this one has to have 2. But you can assess that, like, it goes from 1.5 to 2.5. So the width is 1. And so how much I have to have my height? Well, exactly 0.1. So if you come here, and I will set up this exactly to 0.1. Okay? All right, so I'm going to do the next one directly. This area here has to be 0.3, right? It's the probability that my random variable is 3. Well, the area should be 0.3. The width is 1, so the height needs to be 0.3. Okay? And it is, right? I'm setting up my rectangle to be 0.3. And finally, this area here has to be equal to 0.4. The base is 1. 1 times the height needs to be 0.4, so the height is 0.4. Okay? This is a histogram. So when you look at a histogram, you have everything you need. You have, well, the middle points are your values, and the height times the width gives you the probability. Okay? And what is good in doing that? Well, it's visual, right? So if I give you this table, like I know that you can, if I give you the table, the PDF table here, I know that you can find me the most probable number, but when you see it, right, the bars are representing like this likelihood, right? So which one is more probable? Well, it's more probable that your variable assume 4, and then 3, and then 1, and then 2, right? So it's visual. It's easier to understand. Okay? Good? Okay, so now that you know how to do a histogram, I want to help. It's not this exercise yet. So it's I flipped up something here. Sorry, just copied. Let's make a histogram real quick. The histogram of a fair coin, a toss of a fair coin. So this is my variable x. Oops, sorry. This is my variable x. To column here, and it can, so x can be 0 if it's tails, and 1 if heads. Okay. So let's start the procedure. We start with centering the rectangles in the values that my variable can take, right? My variable can be 0. My variable can be 1. My variable can be, let me put a little closer, 1. So I will start doing like a mock histogram. I don't know the heights yet, but I'm just doing some rectangles randomly with the heights random. I'm not setting up the heights yet. Okay? But I know that they have to be centered in 0, and they have to meet. So they will have to meet in the middle of the interval. Okay, so this is they will have to meet at a half. Okay, good. And well, if this is a half of the rectangle is a half, the other half of the rectangle is a half, so this is 1.5, this is that, okay? Right, now what is the area of this? If it's a fair coin, what's the probability of having 0, of having tails? A half, right? So this height, sometimes you will see the graph with here like this. Sometimes you will see just the bar with the value of the height on top of it, like a half, okay? Okay, what's the probability of the other one? Well, it's also a half, so I have to correct my mock histogram because they have to have the same height. Okay? So they have to have the same height. And this is the histogram of a fair coin. Okay? It's just 2 columns with the same height. Now, what if I showed you a histogram like this? I told you, I tell you that this is a toss. And I show you this. What can you tell me about this histogram? What can you tell me about my experiment? The coin is unfair, right? Because having heads is it's 3 times more probable than having tails. So it's very visual, and it informs you. Like the probability is the area, right? Cool? Good? All right, but nothing is that good to be true. Sometimes our width is not 1. Okay, so let's make an example where the width of the histogram is not 1. And it happens all the time, okay? So I'm giving this distribution function, and I want to construct a histogram. Okay? So again, I will center -2, 0, 2, and 4. I will center my rectangles, my mock rectangles. I will center on these variables, on these values, right? So I'm going to do like, oh, maybe this is like this. I don't know. I don't know the heights yet. Maybe this is like that. Maybe this is like this. Maybe this is like that, right? But I'm centering them in the values, and I'm making them touch, right? So if I'm making them touch, so let's take this one here is easier to analyze because you don't have the negative. Like if this is 2, I'm in the middle, okay? And I meet here, right? And this is 0, and I also meet here. So this grows to the right and meet there. This grows to the left and meet there. What's this value here? 1, right? Okay? And then if this is 1 to 2, this is 2 to 3, this is 4 to 5, this is -1, and this is -3, right? So the first thing, position your rectangles, make them touch, and then find these intervals, okay? All right, so now what's the last thing? Well, the last thing is the area have to give me the probability, okay? Now, here's a question. Let's start in order. No, I usually like to start with the, so it's just a tip. You don't need to do that, but start with the smaller probability. Okay? So the smaller probability is this, right? That's the probability of your variable, assume 2. So here is this is my, this is my rectangle of interest, right? This is my rectangle of interest. It's exactly this one that I had the arrow, because it's centered in 2. Now we have to find the height. So the area of this thing, so I'm going to do this. The area of this thing should give me 0. How can I calculate the area? Well, it's the width times the height. How much is the width? Again, put your dental floss between 1 and 3. How long is this? How long is this dental floss? 2, right? Well, so I have 2 times what height should it be to be equal to 0? 0. Well, I cannot have this, my variable for sure will never assume the value 0. So I'm going to correct my mock histogram, because this rectangle has to be height of 0. Okay? Now let's go to the next one. It's this one, right? So I'm going to my rectangle of interest. Is this one here, is the last one, because it's centered in 4. And the area of this little rectangle have to be equal to 0.2, right? And this 0.2 is the result of width, oh my goodness, of width times height. Okay, so 0.2 is equal to width. Width is, what's the width of these rectangles? It's 2. All of them have width 2. So what is my height? It's a number that multiplied by 2 gives me 0.2. It has to be 0.1. So actually my height is 0.1. Oh my God, but it's not the same number as the PDF. Yes, it's not, because the histogram, the area of the rectangle has to be equal to the PDF. And if you think about 0.1 times the width, which is 2, will actually give you the same value as the PDF. Okay? So if you're doubling the width, you will see a PDF, a histogram that has half of the height. Okay? So I did this. So I'm telling that this is height 0.1. Okay? Now, let's do it automatically here. What is, my next one is the first one, is what's the probability of my variable being -2? Well, it should be 0.3, but if I do that, if I put 0.3 here, my probability won't be 0.3, because it will be 0.3 times the base, times the width, and the width is 2. So, no, if I have a base of 2, I want to put a half of the value here. This has to be 0.15, because 0.15 times 2 equals to 0.3. Okay? Good? So this is my second, and it has to be bigger than the last one, right? Because it's a little bit bigger. So you correct your drawing to account for that. And finally, the last one is the probability that your variable assumes 0. Well, the probability that your variable assumes 0 is a half. So the area of this last rectangle should be a half, okay? But I know that the width is 2, so the height has to be 0.25. Okay, and let me correct a little bit the height. So I want to make it a little higher than it is. So I'm going to, just to kind of maintain proportionality, it would be like this. Okay, so this is the histogram. Now, when you're reading the histogram, you always have to think about the area and not the number of the height. Well, if the base is, if the width is 1, that's automatically like the height. But if it's not, you always need to think about the multiplication of the width with the height. Okay? So it's very visual. Even if the values that are printed are not the probability, it's half of the probability. Because everyone is half of the probability, you still have the proportionality of which one is more likely than the other. So in this case, your variable is much more likely to be 0 with a 50% chance, which is 25% times the base, 2%, 2, okay? And then minus 2, and then 4. Good? So just to, I can't save it. Let me, so just to clarify, so this was my version done by like here, but here is a more, like doing the computer histogram so that you can have it less messy. The histograms will not be asked directly. Like you won't be asked in the test to build a histogram or to like read a histogram. Like there's no questions about histograms in the final. But you will have to you can use it as a tool for normal approximation, for example, which is another content that will come. It's yet to come. So although it's not a direct thing in the test, I really suggest that you practice a bit with the histograms and know how to do a histogram, how to read a histogram, because it will be useful. Okay, although it's not directly asked about histograms. Okay? All right, so in the other section I stopped here because tomorrow is a test. I would introduce new content, and I think you have enough to study already. So we will continue the next lecture on Tuesday.